Have you ever ridden on a roller coaster, flown in an airplane, or driven across a giant bridge and wondered how people know it's safe? What about the pipelines underground that carry water, oil, or gas for miles and miles? Engineers have a way to check all of these things for hidden cracks or damages without taking them apart or breaking them open. It's called nondestructive testing, or NDT. NDT uses science and technology, like sound waves, X-rays, magnets, and even robots, to look inside materials and find problems before they become dangerous. It's kind of like giving machines and structures a checkup, just like a doctor checks your body. And today, you're going to become an NDT inspector and try it yourself. Ultrasonic testing, or UT in a box, Find the Hidden Flaws, was made possible through a generous grant from the Battelle Foundation to help students explore the science behind non-destructive testing and UT. Your mission is simple: find a hidden flaw without ever seeing it. In the real world, engineers use a method called ultrasonic testing to inspect airplanes, bridges, pipelines, and other important structures for hidden cracks or damage. They send sound waves into a material and study how those waves bounce back, kind of like an echo. In this activity, you'll use a slinky to model how ultrasonic waves travel, reflect, and reveal hidden problems inside a material. By observing the waves carefully, you'll think and work like a real NDT inspector. First, stretch the slinky between two people or attach one end to a chair. Now, create a wave by quickly pushing and releasing one end of the slinky. Watch closely as the wave travels down the coils. Did you notice something interesting? The wave moves through the slinky, but the slinky itself doesn't travel down the line. That's because the energy is moving, not the material itself. This is similar to how real ultrasonic sound waves move through metal, concrete, or other materials during non-destructive testing. Engineers study how those waves travel and bounce back to help detect hidden cracks or flaws. Next, let's change it up a bit. You can also place a slinky on a table or flat surface and secure the opposite end using one of the included dot stickers or tape if that's accessible. Then send the wave again. Did the wave move differently this time? Smooth surfaces create faster waves, while rough surfaces create slower waves. In the real world, waves travel differently through different materials. Engineers study those changes to learn what's happening inside bridges, airplanes, pipelines, and other important structures. Now it's time for the real challenge. One person adds a flaw using a clothespin or washer. Then send another wave through the slinky. Did you see part of the wave bounce back? That bounce is called a reflection. When waves hit something different, like a crack, defect, or hidden object, they reflect back toward the source. Real ultrasonic testing works the same way. Engineers send sound waves into materials and study the reflections to detect hidden cracks or damage without ever cutting anything open. Now, use the measuring string to estimate where the hidden flaw is located. Did larger objects create bigger reflections? Did the wave bounce back faster or slower? These are the same clues real NDT professionals use to investigate what's happening inside materials. By studying how waves move and reflect, engineers can locate hidden problems and help keep airplanes, bridges, pipelines, and other structures safe. Like we said previously, engineers and inspectors use NDT to check airplanes, bridges, pipelines, but also power plants, spacecrafts, and even medical equipment without taking them apart or damaging them. The same science behind this equipment is also used in medical ultrasounds to help doctors safely look inside the human body. And it all starts with curiosity, observation, and problem solving. Today, you didn't just do an experiment. You thought like an engineer. You worked like a real NDT inspector, and you used science to uncover something hidden.